Hi guys. So in this lecture, we're going to look at how to derive Boolean expressions from logic circuits, okay? Which means that given a certain combination of different logic gates with different outputs tied together in such and such a manner, how do I derive the final output expression and also simplify the outputs that I get, okay? So that's what we're going to be handling in this lecture. So let's look at our first example. We have input A. We have input A tied into an AND gate, okay? So this is an AND gate. So a final gate is a triple OR gate, a 3-input OR gate, which means that at the end of the day, we're expecting a sum of three things: something or something or something. So this usually helps in clarifying your answer, looking at your final gate and checking, okay, what do I expect? If my final gate was a 4-input AND gate, okay, then that means I would expect something ANDed with something in such and such a manner, okay? So let's move on. How do we go about this? The best way, most foolproof way to go about this is to, okay, so the junction is actually across B. Okay, probably that wasn't clear enough. So the best way to go about this is to literally follow each sequence gate by gate and take note of the inputs and the outputs. Okay, so let's look at it. Our first gate here, we have A as our inputs going straight in, and the second line is coming from junction B. Okay, so that means A goes in here, B goes in here, and out of my AND gate comes AB. Literally AB. Okay, so that's the first step. That's the first step. We look at our second gate and we try and ask ourselves, what's happening? This is tied to a function of 2 gates, so we have to simplify that first. Usually you start from the left, you move from left to right. Okay, so you move from left to right. You should have started with this gate. Okay, so let's handle this gate first. So here we have B being ORed with C, which means that the output of this gate is going to be B or C. So as B or C. Okay, so which means that, so we've done the leftmost gate and we start with our right. We've done AB, and our second gate, remember A is being fed into this. Okay, so this is A and this is B or C, which means that the output of this is going to be A and B or C. Cool. We do the next gate. This is still coming into this, so this is still B or C, and then this is B. Okay, since it's being tied to this junction here, so this is B. The output of that AND gate is going to be B and B or C. So during the final operation, we're going to end up with AB or A and B or C, or B and B or C. Okay, so that's what we need to do. We've done the simple question of deriving the Boolean expression of this logic circuit. Okay, remember you start from the leftmost, literally follow your outputs. So this is B, this is C, and follow them right across step by step until you land at the final gate. So sometimes you may be asked, okay, so let's write this. Give ourselves a bit more space. So this is AB, or A and B or C, or B or C. Okay, so let's now try to simplify our expression using Boolean principles. Okay, this is what we're starting with: AB or A and B or C, or B and B or C. Okay, it usually helps to expand whatever you have. First of all, whatever you have in the brackets. Okay, so we have AB or AB or AC or BB or BC. Okay, so now we can really start applying Boolean principles. Okay, A or A is going to give us, so remember, A or A is going to give us A. So both of these are going to reduce to AB. So we're going to end up with AB plus AC plus BB. So A and A is going to give us A. Okay, So that means BB is going to reduce to B, and BC is going to stay as BC. All right. So now we have a floating B, and we have B in some terms here. We're now going to perform the swallow, the absorb and swallow technique. Okay, which means you factorize your lone variable with something that has this product to reduce the terms you have in your final expression. So let's see what that's going to look like. We keep AB, we keep AC, and now I want to factorize B out of B and BC. So that's B into 1 or C. Okay? Remember, this 1 or C is going to equal, so A or 1 is going to equal 1. Okay? Which means that this reduces to 1 entirely. So B literally absorbed this term BC since it had its own product in there. So we're going to end up with AB or AC or B. Okay? If you look closely, we have B over here. And if you're sneaky enough, we can perform our nice little absorption tactic here. So factorize now B. We have B into 1 plus A plus AC. Remember, 1 plus 1 or A reduces to 1. So that leaves us with B or AC, which is our final expression. Okay, so you should just take it step by step, expand whatever brackets you have. Remember the Boolean identities, pardon me. Okay, A or A is A and A is A, and A or 1 is going to give you 1. Okay, so if we were to ask to simplify this, to draw a simplified circuit of this, then this entire thing that we have here will reduce to, okay, so let's give ourselves a bit more space. So it reduced to B or AC, right? So if we're to draw the simplified logic diagram of this, remember we have A and C are being ANDed together. So that means these guys will form an AND gate. Pardon me. Okay. These guys will form an AND gate in such and such a manner. 1. Okay. And these guys will join into an OR gate since our two terms are being ORed together. Okay. So this will be A, this will be C, this will be B. Out of this will come AC, B will enter here, and we'll have our final expression B or AC into this. So that's literally how it's done. Just take it step by step. You start from the leftmost gate, take it little by little. What goes into my gate, what comes out of my gate, what goes into my gate, what comes out of my gate, and into the next gate. And those are literally the steps you have to take to simplify such an expression. Okay, so let's tackle the second question we have here. We have 3 gates. They all at the same level. So we can, by level, I mean from the leftmost side, they all appear on the same line, right? So we know we're going to tackle this, then this, then this, which is our final expression. Okay. So our final gate is a 2-input OR gate, which means we're expecting something like a certain product term or another term. Okay. So that also gives you a scope of what your answer should look like. So let's get into applying the steps we mentioned. Okay. A follows straight into here, and B also follows straight into here. Okay. Which means that out of this gate comes product AB. All right. It's literally that simple. B follows into here, and out of this gate, B comes into here. But this is an OR gate. So following from this is going to be B or C. Okay. C comes into here, B comes into here. Following from this is an AND gate. We're going to end up with BC. Okay. So remember, we have B or C, and we have BC here. This is an AND gate. We're going to have a product. So we're going to have BC and B or C. Okay. So that's what enters here, and AB enters this gate. So this is an OR gate, which means we're going to have AB as a final answer, AB or BC into B or C, which is really that simple. So no matter how complex the logic circuits might look from the beginning, just start from the leftmost side, take each gate bit by bit until you land at your final gate with your final answer. Okay, so what do we have? We have AB or BC into B or C. All right. So let's see if we can go ahead and simplify this. AB, remember we have to expand our brackets. So that's going to be BBC plus BCC. All right. So remember our binary laws, right? AA is always going to give us A, right? So that means this reduces to AB or BC or BC. Okay? So literally the same thing is almost going to apply here. A or A is going to give us A. Okay? So these guys are going to join together. So AB or BC. And B is common, so we can factorize our B into A or C. Same as B and A or C. Okay? If it's draw an AND gate of this, okay? If you were to draw a logic gate of this from your simplified expression, you have an OR gate for A and C. So you could start with that. An OR gate for A and C. And then an AND gate for B. Okay? And then an AND gate for B. And out of this will come your final answer. A, C, B, A or C, B into A or C. So that's all there is to getting Boolean expressions from logic circuits. Remember, you start from the leftmost side. Trace your inputs going into your circuit carefully. Be careful of junctions, okay? So note what comes into what and what feeds into what. Since it would be sort of messy to keep drawing lines for B and C and B coming into this, right? So write it, get your final expression and see if you can perform any simplifications, all right? So thanks for watching and I'll see you in the next video.